This is question 7 on the January 2010 C1 paper from OCR, and you've got to match these 4 graphs to 3 equations. Then you've got to comment on the one which hasn't matched up later on. So if we look at these, they're all quadratic graphs. They've all got x squareds in. You can tell that from down here and from the shape of the curves. 2 of them are sort of upside down, if you want to think of it that way, or some people call those sad graphs, and 2 of them are sort of happy graphs. This shape, the happy ones, have a plus x squared in them, and these shapes, the sad ones, have a minus x squared in them. So if you look at those, and you look at the equations we've got here as well, there's one of these which may be the most obvious one that stands out first of all. Y equals x squared plus 9, that is a normal y equals x squared curve, which will cross the axis at the origin, and plus 9 means it's been shifted up 9 units, and that one matches with this one here in the diagram. So figure 1 matches with A, and that's the first one. That's B, figure 1 matches with B, the one we've been speaking about, and that's the first one we can match up. So figure 1 and B, that one is now out of the running for the other ones, and we can ignore that one there. That one has been dealt with. So if we look at the other 2 equations we've got, the next equation we've got to look at is y equals 3 minus x all squared. Now one thing you can think of here is, what are the roots of that? Where would that cross the x-axis? What value of x makes this whole thing here 0? Well, for this to be 0, the bracket has to be 0. And the number that makes the bracket 0 is if x is equal to 3. Because 3 minus 3 is 0, and 0 squared is 0. That tells us that this curve crosses the x-axis at 3. It doesn't cross it anywhere else. So immediately that rules out this graph here, which is crossing at minus 3 and plus 3. So it reduces it down to this one here, or to this one here. Both of those cross at 3. Now if I multiply the brackets out here, 3 minus x all squared means 3 minus x times 3 minus x. If I multiply that out, I will get 9 minus 6x plus x squared. And the plus, the positive x squared, means this graph is that shape, not that shape. That shape would have come from a minus x squared. So I'm looking for a graph that looks like that. And if I look at the exam paper, that graph then is this one here, figure C. So C on the exam paper, figure 3 on the exam paper rather, figure 3 on the exam paper matches up with A. So that one goes with this one here. So if we look at the equation we've got left on the exam paper, it is y equals 3 minus x times by x plus 3. And again, let's see what value of x makes this 0. Well, if that x there is replaced by a 3, this bracket becomes 3 minus 3, which is 0, and 0 times by anything is 0. So that tells us that this graph will cross the x-axis at 3. Here, what makes this bracket 0 is if that x is minus 3. So we know also that this graph crosses the x-axis at minus 3. And if we multiply this out, we will get, if we multiply those 2 bits together, we'll get 3x. Those 2 bits together will get plus 9. Those 2 bits together, minus x squared. Those 2 bits together, minus 3x. So we're getting 9 minus x squared. And that minus in front of the x squared means the graph is going to be that shape. So we know it's going through those 2 points. So this graph has got to look like that. And we also know, because we've now found the equation is y equals 9 minus x squared, that when x is nothing, that whole bit will just disappear and we'll get y is 9. So we also know that this curve goes through that point. So for curve equation C, that matches up with this one here, which is figure 4. So figure 4 goes with C. So we're left now with the second part of the question saying, give the equation of the curve which does not correspond to any of the equations in part 1. So we're looking at this curve up here. Well, if you start with the normal y equals x squared curve, If you then shifted that, which should be going through the origin, if you shifted that 3 units to the right, you would get that. And then if that was reflected in the x-axis, you would get that, which is what we want. So this one here is y equals x squared, a straightforward one. Shifting it 3 to the right means you replace the x with x minus 3. And minus 3 in the bracket shifts it 3 units to the right. And here this is a reflection in the x-axis. And for a reflection in the x-axis, you just stick a minus in front of everything you previously had. So that is the equation of the graph in figure 2. And it's worth pointing out that if you just wrote down that minus x minus 3 all squared, because that's not an equation, it hasn't got a y equals at the beginning, you would have lost 1 mark. For an equation, you must make sure you always include an equal sign.